the next question is, if the letters of the word attraction are written at random, find the probability that all T's occur together and no two T's occur together. Now the letters in the word attraction, 10 letters are there. So total number of arrangements is equals to 10 factorial upon, since there are 3 T's, so upon 3 factorial and 2 A's upon 2 factorial. 10 factorial upon 3 factorial into 2 factorial. Now the question is, all the T's occur together. Since there are 3 T's, take all the 3 T's as one letter. If we take all the 3 T's as one letter, 10 minus 3, 7, and all T's as 1. Now we have 8 letters. Now how can we arrange these 8 letters? 8 letters can be arranged in 8 factorial upon. We have considered all the 3 T's as 1. Now there are 2 A's. So 8 factorial upon 2 factorial. Now the required probability is 8 factorial upon 2 factorial, 10 factorial, 3 factorial and 2 factorial. 8 factorial, we can write 10 factorial as 10 into 9 into 8 factorial, 3 factorial, 3 into 2. So we get the answer as 1 by 15. I am again repeating, total number of letters in the word attraction are 10. So total number of arrangements are 10 factorial, 3 T's, so upon 3 factorial and 2 A's, 2 factorial. Now if we consider all the 3 T's as one letter, then total number of letters we have 8. And 8 letters can be arranged in 8 factorial upon 2 factorial ways. So required probability is 8 factorial upon 2 factorial upon 10 factorial upon 3 factorial and 2 factorial. After solving it, we get the answer as 1 by 15. Note it down. Now the second part is, no two T's occur together. No two T's occur together if no two T's occur together except T, there are 7 letters and we can arrange 7 letters in 7 factorial and 2 A's are there upon 2 factorial. We can arrange 7 letters as 7 factorial upon 2 factorial. Now there are 6 letters between 7 letters and 1 letter on extreme left and 1 on extreme right. Now we have 8 letters. Out of 8 we have to manage all the 3 T's but not occur together. So we can arrange 3 T's out of 8 in 8C3 ways. So the required probability is 7 factorial upon 2 factorial into 8C3 upon 10 factorial, 3 factorial and 2 factorial. Now solve it. What we get? 7 factorial, 2 factorial will get cancelled, 3 factorial, 3 into 2, 8C3, 8 factorial upon 3, 8 minus 3 is 5 factorial. Now we have to solve this. 3 factorial will get cancelled, 7 factorial, 10 into 9 into 8 into 7 factorial, 8 into 6, 7 into 6 into 5 factorial upon 5 factorial. It will get cancelled. The answer is 7 by 15. Answer is 7 by 15. Note it down. Now the next question is, what is the probability that for S come consecutively? What is the probability that S come consecutively in the word Mississippi? Now, how many letters are in the word Mississippi? 11 letters are there. So, total number of arrangements are 11 factorial. There are 4 S, 2 P's and 4 I's. So total number of arrangements are 11 factorial, 4 factorial, 4 factorial and 2 factorial. Now if we consider all the 4 S as one letter, then the letters are 8, and now 8 letters can be arranged in 8 factorial, 4s as one letter, but there are 4 i's and 2 p's. So 8 factorial upon 4 factorial into 2 factorial. So the required probability is 8 factorial upon 4 factorial, 2 factorial, 11 factorial, 4, 4 and 2. Write 8 factorial as it is. 4 factorial will goes in the numerator, 4 into 3 into 2 into 1, 11, 10, 9 and 8 factorial. 8 factorial will get cancelled here. This is 4 upon 15 into 11, that is 4 upon 165. 4 upon 165. Note it down. Now next we have addition theorem. If A and B are two events which occur when the random experiment is occurred, if A and B are two events associated with the random experiment, then probability of A union B is probability A plus B minus probability of A intersection B. If A and B are mutually exclusive, we know then probability of A intersection B is 0. Then if A and B are mutually exclusive, then probability of A union B is probability of A plus probability of B. When A and B are mutually exclusive. Now if exactly one of the events from A and B occur, then it is equals to probability of exactly one event occur. So what is the probability for that? Probability A plus probability of B minus 2 times probability of A intersection B. Now on the basis of this theorem, we will solve the questions. Let us start. Question number 5. The statement is, a basket contains 20 apples, 10 oranges. Basket contains 20 apples and 10 oranges, out of which 5 both are good. Now we have to select 2 out of 30. Since there are 20 apples and 10 oranges, so total is 30. Total items are 30 and we have to select 2. So total number of arrangements is 30C2. 30C2, 30 factorial upon 2. 30 minus 2 is 28. So 30 into 29 into 28 factorial, 2 into 28 factorial. 15 into 29, that is 435. Now both are apples or both are good. So we want to find probability of A union B. Both are apples or both are good. We know the formula, probability A plus B minus probability A intersection B. Now first we have to find these probabilities. Probability of A. What is A? Both are apples. Total number of apples we have 20 and we have to select 2 apples. So 20C2 upon 30C2. 20C2, 20 factorial, 20 minus 2 is 18. So 20 into 19, 18 factorial will get cancelled. So 190 upon 435. Is it clear? What we have done here, there are 20 apples and 10 oranges. So total number of items are 30. We have to select 2 items which are either both are apples or both are goods. We have taken let A the event that both are apples and B is the event both are good. Now we want to find probability A union B. We have the formula for this, probability A plus probability B minus probability A intersection B. Probability A is both are apples. Since we have 20 apples and we have to select 2, so 20C2 upon 30C2. Now probability of B. What is the probability of B? B is both are good. Both are good. How many items we have defective? 8. Out of 30, 8 items are defective. So good items are 30 minus 8. That is 22. So we have to select 2 items from these 22. So 22C2 upon 30C2. 22C2 is equals to 22 factorial. 22 minus 2 is 20. So 22 into 21 by 2, 11 into 21, 231. So we have 231 upon 435. 231 upon 435. Now we want to find probability of A intersection B. What is A intersection B? Both are apples and both are good. Now we have 20 apples out of which 5 are defective. So good apples are 15. Now we have to select 2 items from 15. 15C2 upon 30C2. Find the value of 15C2. 15 factorial. 15 minus 2, 13 factorial. 15 into 14 by 2. 105 upon 435. Now put these values. 190 plus 231 minus 105 upon 435. 231 plus 190. 421 minus 105 upon 435. 316 upon 435. Note it down. electric contract. Probability that person gets electric contract is 2 by 5. Probability that he will not getting plumbing contract. Maybe the event person gets plumbing contract, but he is not getting the plumbing contract. Its probability is 4 by 7. If the probability of getting at least one contract is 2 by 3, getting at least one contract is 2 by 3, what is the probability that he will get both? दोनों उसे मिल जाए उसकी probability क्या है? So what we want to find this, we know that total probability is 1. So probability B plus B dash is equals to 1. So probability of B is 1 minus 4 by 7, that is 3 by 7. Now we will use the formula here. Probability A union B is equals to probability A plus probability B minus probability A intersection B. Probability of A plus probability of B, we want to find A intersection B probability. Probability A union B is 2 by 3. Probability A intersection B is equals to 2 by 5 plus 3 by 7 minus 2 by 3. Now take the LCM of 5, 3 and 7. All are different. So 5 into 3, 15 into 7. 105, 5, 21 into 2, 7, 15 into 3, 35 into 2 is 70. 87 minus 70, 17 upon 105. So 17 upon 105. Note it down. Now the next question is question number 7. Let A, B, C be 3 events if the probability of occurring exactly one event out of A and B. अभी हमने पढ़ा था कि exactly अगर one event occur करता है A और B में से तो probability A that is equals to probability A plus B minus 2 times probability A intersection B. Probability exactly one of two events A and B occur is 1 minus X. And out of B and C is 1 minus 2X. Out of C and A is 1 minus X. And that of occurring of 3 events simultaneously. तीनों events occur करते हैं simultaneously, that is x square. Then prove that the probability of at least one out of A, B and C occur is greater than 1 by 2. Now probability, this is occurrence of B and C. C and A. Let this equation be 1, 2 and 3. Now add equation 1, 2 and 3. After adding, what we get? Probability A plus probability A, 2 times probability A plus 2 times probability B, 2 times probability C. This is 2 times taking 2 common minus probability A intersection B minus probability B intersection C, C intersection A is equals to, add all these terms, 1 plus 2 plus 1, 3, 2, 3 and 4x. These two come on this side, right hand side, so it becomes 3 minus 4x by 2. Now what is he saying? What is the probability? At least one out of A, B and C. At least one out of, that is A union B union C, equals to probability A plus probability B plus C minus probability A intersection B, B intersection C, C intersection A minus probability A intersection B intersection C minus probability A intersection B intersection C. Now we have the value of this as 3 minus 4